In this session, we will look at the difference between resistance, resistivity and the relation between them. Suppose you have a conductor which is connected to a cell like this. Then there will be a uniform current that is set up in the conductor. We draw it from the positive terminal through the conductor to the negative terminal. Though the discussion is about resistance and resistivity, let me emphasize that current should not be understood like starting from positive terminal and ending at negative terminal. We have to begin drawing the arrows somewhere and therefore we draw it here. But otherwise, the moment the plug key is closed, I did not show this plug key here because it is only a theoretical circuit, but the moment the plug key is closed, the current is established in the entire circuit at once. It is not like one coming after the other. It does not happen that way. Many students have that misconception. So the current flows in the circuit like this. And when the current is flowing in it, this current that is flowing in the circuit will depend on the value of resistance of this resistor. Now the resistor that is being used in this circuit, its value will depend on certain other parameters, and those parameters are that the resistance of the resistor is directly proportional to the length and resistance of the resistor is inversely proportional to the area of cross section. Let us understand the reason for these two things first. Resistance will be inversely proportional to area of cross section because when the area of cross section increases, there is a lot of cross sectional area available for all the charged particles to move through. So when they are getting a greater facility to move, then they are experiencing lesser opposition. When it is lesser opposition, therefore you say it is lesser resistance. So the greater the area, lesser the resistance. Lesser the area, greater is the resistance. So this is fair enough. Coming to this one, resistance being directly proportional to length. Many students have a misconception here that if there is a conductor of small length like this, when compared to a conductor of a larger length like this, if it is a small conductor, then the charged particles will have to move like this. They don't move in a straight line and they reach here. You know that this is because of numerous collisions that take place. Whereas if the conductor is long, then the collisions will take place much more and there will be lots and lots of haphazard movement before the charged particles actually manage to come here. Therefore, they end up believing that there are more number of collisions and therefore the resistance increases with length. This is wrong. Resistance does depend on length, but the reason is not because the charged particles have to travel a greater length. That is fundamentally wrong, right? But then why does resistance depend directly on length? It is more to do with the cell that is connected. When the cell is connected across a resistor, then there is an electric field set up. This electric field depends on the potential of the cell and the length of this resistor. It is that electric field which acts like a motivation, and the electric field motivates the charged particles to move forward, and therefore as the length increases, the electric field strength decreases. You will learn more about this in the 12th class. I am just giving you a qualitative argument, not a quantitative one. In 12th class, you will have a derivation for that. The resistance increases with length because as the length increases, the electric field decreases. Electric field is the motivation, so the motivation decreases, and when the motivation decreases, current decreases. When the current decreases, the resistance increases. That is the actual reason. Now, these two relations can be clubbed into a single relation and you can write R is equal to rho into L by A. This rho here is called resistivity. This one is resistance, this is resistivity. Now, there are two different ways of looking at it. One is a purely mathematical pursuit. There are two equations, you club them and you get the third equation. Physics wise speaking, when the resistance depends on the length, when the resistance depends on area, it also has to depend on the material, because gold will not have the same resistance as silver, silver will not have the same resistance as copper. Therefore, the dependency of the resistance on the material is indicated by this term called resistivity. Now coming to your 10th class definition, Resistivity is the resistance of a material of unit length and unit area of cross section. When you make both of them 1 and 1, then the value of resistance that you get will be numerically equal to resistivity. This is how resistivity and resistance are related to each other. I hope all of you understood it.